8x8 wood. 0 ply works, and I think a 1 ply works as well. Yep, so let's suppress all this debug output. I'm already suppressing that it is being generated. Let's just not print it, basically. Let's make this 2 ply. And then we start printing from 2. That should be equal to max ply plus 1. So 3, 4, 0, 1 and 2, and we only print 2. There's only 2 of those. Yeah, of course black is to move. If black can do any move, is allowed to do a move, and then we have to give mate immediately, then there is only one solution. That is this. So black goes there, and then we give mate. And the mirror, all that, obviously. So before we also had only 2 positions with mate in 2 ply. Zero ply, I'm not printing them. Plus what? Yeah, this stopped at 1. Sorry, I have to scroll up further. Here's 3 ply, 2 ply. Yeah, 1 ply. Only 2 positions for 2 ply. Therefore, 3 ply are the only positions with black. This is with white to move. White must do a move such that the position is one of these. Therefore, black must still be in the corner. So quite obviously, white has to go here, and it cannot come from there or there. It can also not come from there, because then white could give mate on 1 ply. And this is the mirrored case of that. So it could come from here, I think. Yeah. Or any of these 3. Yeah, this is not this is not possible, so it could come from here and go there. That would be this one. Or it does a rook move. So it came from here, or it comes from here. Or it comes from here, going there. Still needing to see that one. That will be this one. Yeah. And then from here you can go from here to there, but if the king is here, just give mate directly. So the king cannot be here or here. The mirrored positions are over here. Yes. And these are special. You have to remove the rook over there. No, further over here. And then just king moves and mates. So this is correct, actually. I think these are indeed all the positions that are made in 3-ply. Let's go to 3-ply then, and print 3-ply. So I'm gonna look at it again. Yeah, well. Yep. And the big surprise, nothing. Why? Why on earth? I think that the reason might be that the only way to get one of these made in 3-ply positions where black was the last one that did a move is where black can do another move. I mean, black is never going to voluntarily go into the corner. If it came from here, it would be illegal. If it came from here, it would just step over there instead. But that is, of course, impossible. There must be made in 4-ply. Must be. How is it that we can't find that? Yeah, what? I think it literally cannot find any made in 4-ply that ends in one of these positions. So if this is made in 3-ply, if these are all the positions that are made in 3-ply, Something horribly is missing here, but what? These cannot be all the positions that are made in 3-ply. It's just impossible. Let's try to find a position that is made in 4-ply. It is made in 1, 2, 3, 4-ply. Black to move. No matter what black does. Actually, black could go here. That's made directly, so black won't do that. If black goes to A8, it is also made. So back in 4-ply. So black can go to A7 or A8. And there is no reason not to go here. At which point we should have a mate in 3-ply. And we do. So, apart from that, this is also made in 3-ply. Also did not find this one. Oh, that's maybe the reason. So if the king is here, no, it's searching backwards. So I think that what happens is the king is, oh boy, this was the move. Yep. So we switch backwards from this position. I think we have this position as made in 2-ply. With white to move. There are only 2 of them. That's this position, right? No. No, the king must be here. Okay, whatever. So this rook then, and the king like that. This is made in 2-ply with black to move. Now that would be 2-ply. 1, 2. Which means that the last move is the move by white. So yeah, this is made in 3-ply. And white has to go there. If white is to move, it is 1, 2, 3, and this is the only solution. Going there. The rest is longer. So this was made in 3-ply. This is printing 2. This is 3. Should be able to find this one. This one here. That rook. And now we're going to look backwards from here, and then it finds that if the black king was there, then black can choose to go here with the result of made in 3-ply. It will not go here because then white can give a mate immediately. But it will also not go into the corner because this is a better move, going from here to there. It thinks. And it thinks that because this move doesn't exist, so it thinks that that is not mate in 2-ply. And therefore this one is rejected. So if the king is here, it will not go there. So from here we do find that position, but then reject it because it seems that black just should not go to the corner. Black should go there. Meaning that, so if black would have gone not in the corner but there, then that is better, it thinks. Well, in fact, this is also made in 3-ply. Wait a minute. I'm so confused now. This is made in 2-ply. No, it's not. Wait a minute. How can it be made in 2-ply? Why does the move now? It's still 3-ply. Okay, if we go here, then white is to play. 1, 2, 3-ply. Yeah, okay. And the other one as well. So if it went there, it's also 3-ply. So I think the reason that we don't find the 4-ply, this one, is because we don't have this position as 3-ply. And I know we don't, because all 3-plies have the king in the corner. So then the question is, why do we not have a 3-ply with the king in the corner? Well, it should have found this one from the 2-ply position, of course. So what is the 2-ply position? The 2-ply position is this one. And we don't have this one either. So we're missing the 2-ply position. This position will black to move. Black is forced to go there, and then 2-ply is made. So why do we not have this one? And I looked at it and I was convinced that we did have it. They said, oh yeah, this is good and this is good, but it isn't. Two ply, and the king is not there. It's missing. Why is this position missing? Well, this is missing maybe because the 1-ply position is missing. I doubt that. Let's print the 1-ply as well. I think you have it here. The 1-ply position would be this move, right? This is in 1-ply, it's just made in 1 with the dead work. So yeah, it's there. So we have this, and then the question is, why are we not finding this move here? So from here we find that position, and then we find the alternative moves, and there is no alternative move. It is just the only move that it can do is this. It's forced. Apparently that is rejected. Okay, how can I debug that? Let's turn on all debugging. So no need to do this. I think this is just printing it. I just need to turn all the debugging on here. not Svalbard. Okay, so in the end we'll have mate that looks like maybe we should just get used to searching it as a string. That is the position, and the position is the black king is at 0, 0, 1, 2. And the white king is at 2, 2. And the rook is at 0, 1, 2, 3, 4, 0. Okay, so we find this mate in one position. Now we're looking for adjacent positions, or preceding positions. One of those positions should be... Oh, it's moving the white rook. But that's not right. No, this is another mate in one position. Huh? Return 0 positions. Okay, so this is the problem here. Adjacent positions is not working. In this position, white is to move, and we give mate. If then I call this, it should return positions where black is to move, and well, where the black king is there. So let's highlight this. Search for it. And turn on way more debugging. Okay, entering king moves for some board where black is to move. Or the black king has to move on, yeah, but it's the same thing. Well, adjacent, I don't know. We are looking for positions where black is to move, such that after black moved, we get this board. Black king 0, 2, that's the current board or the target board or whatever. And then it considers the position that we are after, namely this one. And it says it's not an illegal position. Yay, that's one thing. King moves. Adding position where the black king moved to 0, 1. Well, moved from, but okay. And then we did this one, and that is also being added. Okay, I think this is the dumb thing. It's just generating stuff, checking that it's not illegal. Now we get the adjacent boards. So, okay, the same thing. Now it's called an adjacent board. Created from index 0, which is derived from where the king is here. And now we're going to generate potential alternative positions that it could have done from here. So now we generate forward moves. And there is only one forward move. Entering king moves, board command black, and I forget to print that it is a forward thingy. Yeah, well, I can do that. We can redo that. King moved to, oh sorry, adding position where the is dubious and king moves must print a third argument. So now we're going from this position, same as that one, forward with black to move, I hope. So not super clear that black is to move because it doesn't print it anymore. Oh, that's interesting. The falling board is not illegal. And this position wasn't known, therefore it thinks that this is an escape for the black king. And it is illegal, so that's a really shocker. I'm probably testing it with the wrong color to move. Testing this with black to move, because I know that it is illegal is working. The other one is this one, and it says also this is also not legal. And then we get that one, yeah, also not legal. There is a better move for black, king 0-0, ejecting position 0-1. This is the better move, so let's add a column there. So the color, I think the color that we pass here is the wrong one. The question is, who is to move in the adjacent board? Depends on if we go forward or backwards, actually. Well, let's see. So if you go forward, did I just put it exactly in the wrong place? I think so. Forward means you go from board to adjacent board. This is forward. And I want false, so we have first. P first, damn it. I just want it. So annoying. Oh, wait. That's not where it goes. Just delete all of this. If you go forward, then from the current board, we move the color king. Color is always the color that is being moved. And then we end up in the adjacent board. And if color king is moved, then of course that color was to move before we moved it. And here, therefore, adjacent board must be the opponent to move. But here the adjacent board must be the color that to move because the king is moved. And then we end up here, though now the opponent of the color is the move on the board and the color itself. Yeah, so true means that color opponent must be used. So this is an adjacent position, and now we're going to find alternate positions. And this one is now rejected. Yay! Because, well, it's not printed, because it is illegal. It only prints the legal ones. Might as well not print the legal ones, because if you only print the legal ones, those are also printed as adjacent positions. Or alternate in this case. So that one turns up here. This is an alternate position, but it's not alternate, it is just the only move. And nothing is rejected. What happens? Yeah, now the other adjacent position. So from here the king will not go there. From here the king will go there. We just established that. And now from here it will not go there because it does have better moves. Alternate positions. Well, this is not the alternate position, it's just the position that you want to consider to move to. But you can also move this way. Therefore, it must say that there's a better move for black, king 0,4, rejecting position 0,3. I think it works. It should work. So let's turn all the debug output off again, because, well, too much debug output. I just want to turn everything off. Well, okay, not. Let's just go to the bottom. One ply. Yay, more positions. 2 ply now is this one. Black moves and we give mate. This one, black moves and we give mate. We already had those two. But this one too. Black is forced in the corner and then we can give mate. Black must go in the corner and then we give mate. Black must go opposite of the white king and we give mate. Same thing here. Same thing here. And this is the one that we were missing. Black goes here and you give mate. And so on and so on. So yeah, there were just way more positions that were made into ply. And I guess now we find all of them, which means that we find also the mate in 3 ply now. Yep, now we find mate in 3 ply, where the black king is not in the corner. In particular, I want to find this one test case, of course, or rather the test case that we had. This one? Yeah, this is 1, 2, 3. Seems I'm missing something here. Yeah, this is the one. Yeah, that rook. And the king here. Awesome. Well, why would it not work now? I mean, at some point it just has to start working. Yeah, interesting. So black has to move here, and then white can't give mate because black threatens to escape here. And therefore all of these rooks have to go to this line to cut it off again. And this one can also go there. And then black has to go back. Sorry, black was here, so black has to go back in the corner, and then we give mate. So that would be 1, 2, 3, 4. Yep. Oh, special case where the king is here, the rook can only be there. Oh. Yeah, the fastest way would be the king comes closer, right? So why not go there? Or maybe go here. So faster? Doesn't matter much, I guess. Oh wait, black is the move. Whoops. Okay, black goes here. White goes here, black goes back, and then white gives mate. Yeah. Now, if the white rook was here, why is it then not made in 4-ply? Oh, because then the king can go there, yeah. Then it takes longer. Right, pretty cool. Weird positions. I think it works. Let's find the highest ply that exists. We're on a 5x5 board. Now we can check if that is indeed takes that much. So on a 5x5, I do we do as many plies as we want. Print starting at 4, why not? Made in 20 ply. Holy shit. So it could even be more than that. I don't expect it. I wanna see the maximum, so I thought 20 would have been already, wow, like it doesn't exist. 30. $28, yeah. Oh, this is the maximum then. $28 ply, black to move, which is slightly annoying, but yeah, why not? Let's see. This king is at 1, 2. 1, 2. What? Rook there, about to be taken. And this one is at 3, 4. Yes. Black to move. It is black to play. Ugh, is that, what is the correct English? Well, I guess to play is correct English then. I switched from to play to move because the AI used to move. Maybe both are possible. Black to move takes a rook. What the? What? No. Yeah, black to move. Yeah, black takes a rook. Totally draw. How the hell did this get generated? Damn it. Oh, it just goes on and on and on. Oh no, yeah, here it's even made in 27 ply. The rook is nowhere to be seen. That's why. Okay, so something definitely goes wrong still. Arg. No, nope. That's difficult to debug. think I'm just going to print slowly more until I see something weird. 4 is still looking normally. Well, it looks normal in the sense that there are rooks on the board and black cannot take the rook. So this is of course not correct. Black to move, we just take it. It's definitely not going to mate in 6 ply. So 6 ply is already wrong, okay. So why the hell are we generating this? Same thing here. No, that's not the same thing. Same thing here. Can just take the rook. The problem with debugging this is there is so much information. It's very hard to find back that one thing. Here's also totally wrong. Just take it. I'm just going to go over this one. Zero two two 301. That ain't possible. It's not easy to debug this without seeing who's the move. This is definitely wrong. So this position is generated from the position where the white rook and the black king are on the same square. Or, well, it actually is possible, of course, if we just take the rook. But we should never do that. I mean, after we do that, it's not a mate in so and so many. Apparently thinks that this is made in 5, which is wrong. Why did it think that this is made in 5? Is there now the question? Well, because this is made in 4 without a rook on the board. That's why. I don't really understand it, but this is wrong. You generate this as alternate board going backwards. That creates a rook out of nothing. So the king goes here and then leaves it behind the rook. Or, yeah, because we're going... You see, where does this exactly come from? This comes from adjacent board generated from this position. Let's highlight that one. There's another one that's derived from there. So we enter king moves. Looking for king moves of the black king. Going backwards. And then we generate the backwards position where the king is here. And that's not allowed. But the prince adding position where the black king came from 0-0 and 2-0. It never generated anything, or it came from 0-1. Yet that's returned in the result. How is that possible? So I need to debug king moves where we have this position for color black, and then see how 0-1 ends up in the result. But we're going forward, so it is a legal move. What the hell? Why are we going forward? Huh? True. Try normal forward moves. Why? I don't get it. Where are we then? Yeah, but still, it is generating 3 moves, isn't it? There's obviously only 2 puzzle moves then. You can go there or you can take the rook. So even if you go forward, you should not return 3 positions. I don't know what's happening. It returns nothing. It's called again for the same position. And this time where it's forward is false. Okay, probably need to debug this one then. So this is the second time we come here, but now with forward is false. And then if I do finish, then we have... nobody knows where we finished from. What the hell? 21. Yeah, no, this is the one. Okay, so it's the second time we get there. Run again. Continue. Now it's the case. Okay, and or not, because forward is now again true. What the hell? Okay, I'm losing it, but now this is false, so this should be the one then. It's a third. Okay, the third. So now we're going backwards. Going backwards means that we're going to generate a board where it is black to move. Yes. dx runs from -1 to 1. That is probably not a problem. If current pos x equals 0 and dx is -1, that's not allowed. But current pos is here. We can go there, no problem. If not forward and current pos equals board size -1, well, we're not even in close to the board size. dy also runs from -1 to 1. Did we move it all? Yes. If the current pos y equals 0, and that is the case, and dy equals -1, then we cannot go there. Continue. So now dy is 0. We still moved. This is no longer the case. Not forward. No. Square. So this produces the square 0, 0. Color is black, yes. Adjacent board set a black king square. Color is black, yes. And the adjacent board white hook equals the adjacent king square. Okay, did we take the white rook here? No, because the rook is on 0, 1. And not adjacent, well, it's allowed to take it, but only if we go forward. We're not going forward. So here's the bug. But we'll see that the next one moved in, because this is still allowed. Determine legal, so this is illegal, I think, because adjacent to move is black. And black is in check now. Sorry, it's black to move. What? It's not illegal. Sorry, no, it's not illegal, of course. So we now have that the black king is at 0, 0 in the corner. White king is far away, and the white rook is attacking the black king. So it is in check, but black can just move, so it's not illegal. And so do not go to line 90 or something. Go to 92. Plotting board is not illegal. Adding position with the black king came from 0, 0, yeah. And we add that. That's one possibility. Then dy becomes 1. Well, that is illegal because now next to next to the white king. Adding position of the black king just took the white rook on. Oh, that was, sorry. Dx is still -1. Yeah. So now it failed, but it's adding the position where the black king just took the white rook. That's not true. Forward is false. What do you mean just took? Well, it's just not allowed. Damn it. Can never come from here. Line 81. That's that's where the fix is needed. But even if we skip this, so we do not add that position, then it's still added below here, because this is not going to be triggered. The illegalness sits in the fact that forward is false and these two are equal. That's just the combination is not possible. The white rook cannot come from the square where the black king is. But that is an illegal position, so we would probably never consider it. So maybe I'm really only worried about where the color is black. And which means that the king moved, and the king cannot come from the square where the white rook is. Yeah, can no longer take the rook. Let's try it again. 24 ply, less than 30. Black to move, and black cannot take the rook. At least now the positions look same. And oh, wait a minute. I was like, except here, but now it's white to move. So yeah, this one should work. I can't test this though, because this one is going to give mate in this corner. Test this on an 8x8 board. Maybe it will still work. Let's try this. Let's first try the same one. Well, same. I mean, it's possible that it gives mate in the other corner anyway. Let's try this one. Okay, mate in 24 ply. We'll see. So the king is at 2-2. Is that here? Yes. And the rook is here, and the king is there. And black to move. It's not going up till the mate. Maybe close enough. So it is number of plies 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yes, it was 20. 24, damn it. This is just a one, wait, one more move. No, black is the move. So 1, 2, 3, 4. It's 4 more moves. Yeah, 10. It's 10 times 2 will black to move. It's, I think, 20 ply. So mate in 1 is mate in 2, black to move. No, mate in, sorry, black to move is mate in 1, I think. Yeah, black is to move. So it's just 2 times. Yeah, this is 20 ply. So it's wrong. It's not 24 ply. Oh, except it's using, no, that's good. Still been within the 5x5. Okay, I'm going to bed. So past 1 AM.